Hello everybody and welcome to today's webinar. I'm joined this afternoon by Michael Bolton, who will be presenting on the topic of no test cases required, test sessions chartering. And Michael has been involved in testing for over 25 years. He's the co-founder with James Bach of the Rapid Software Testing course, which is rolled out in many locations around the world. And I'm sure many of you have already attended this course and can see the benefits of it. Michael is a regular speaker at EuroSTAR, and he was even the program chair at the 2013 conference, which took place in Gothenburg. And this year, Michael will be speaking at the EuroSTAR conference, and he'll be giving a full-day tutorial entitled Critical Thinking About Numbers and Metrics, as well as a track talk entitled Transforming Trainees into Testers. So we're delighted that Michael has taken the time out today to come and talk to you all about test cases. If you have any questions for Michael about any of the content that he's about to go through, please type your questions into the questions field there. And at the very end of the webinar, we will go through your questions one by one. So that's enough from me. Let me hand you over to today's presenter, Michael Bolton. Hello, Michael.
Hi, Dara. How are you?
I'm great. I'm great.
Good. Good. I'm speaking to you, of course, here from the DevelopSense studios, high atop Mount Olympus in an isolated chamber. Actually, that's not the case at all. Today is garbage day, so there's noise outside. We've got roofers coming over. I kid you not. We are actually about to have some work done on the roof. And we also have a neurotic dog who goes berserk every time anybody comes to the door. So if there is background noise, please forgive me. I guess it's time for me to show my screen and show you the title slide. It's actually kind of more fun to do this in a dialogue with people. But here's what I will do. I will pretend that I can hear you, and maybe I can monitor you from the chat window a little bit if I see some things going by. So we're going to talk today about no test cases required. And the key word there might be required. A lot of people see no, and then they sort of stop reading after that, and the attention trails off. But what we're saying today is that no test cases required. Let's look at circumstances where we need them and where we might not. So let's start with this. We're making a product. We need you to start testing it right now. That's what they say to you. So what do? Well, everybody knows how to do this properly, right? Two easy things. You prepare test cases, and then you execute test cases. That's how you do testing, just like that. Nice, tidy, factory approach to things. And then a bunch of you are thinking, well, probably it's not like that exactly. It's a little bit, there's more to it than that. We read the specification, see? And then we identify specific items to be checked, and then we prepare test cases. And then we execute test cases. And now I hear in my mind what I often hear when we do this in front of a live crowd. People saying, I don't think it's like that. Okay, so maybe it's more like this. Maybe instead of we prepare test cases and then we execute test cases, maybe it goes like this. Maybe it goes, we read the spec. That's what we do. We read the spec. And then we say, oh my God, there is no spec. This, of course, happens a lot of the time. Or maybe it's not that there is no spec. Maybe it's that there is a spec. And that's okay. To just read that spec, and we have a look at it, and then we realize, oh my God, it's old and it's confusing and it's out of date, and then maybe it's wrong, and maybe it contradicts itself. Maybe it relates to some previous state of what people knew about the product. So what do? Well, maybe the ideal thing to do at that rate would be to ask somebody. Go out and ask somebody, and when we walk around the shop and we ask people about the product, the next thing we find out is, oh my God, nobody actually knows how this thing is supposed to work. Now at that point, a lot of people find themselves asking, is there anything that I can do in order to test this thing? Is there anything that I can test? They ask themselves. And the answer, of course, is you can always test. You can always test. If you don't have a running product, you can test other things. You can test a mock-up of the product. You can test a document describing the product. You can test a diagram that models the product. You can look at a diagram and ask questions about it. You can look at a mind map that somebody has prepared and compare that with what you know about the world and what you know about the product. You can compare you can compare your ideas with a document that describes the product. The point of all this is that no matter what you've always got something to test. Another way of thinking about it is that you've got something that somebody has produced. Somebody has produced an idea or a diagram or a mock-up or a document or some kind of prototype. Any artifact or any idea or any notion that somebody has about the product is something that you can test. Because testing is not simply operating a product and observing its outputs. Testing is the process of evaluating a product by learning about it through exploration and experimentation. And in order to do that, you need models of the product. The good news about all this is that testing isn't really about test cases. I mean, let's think about this. In any complex cognitive domain that I can think of, work is not modeled on the case. Pilots on an airline do not use piloting cases. Parents who are bringing up kids and who are teaching kids and raising them and socializing, parents don't use parenting cases. Researchers, scientific researchers, they have very complex exploration and experimentation with substances and chemicals and products and biological things, but none of them use what we would call research cases. And managers don't use management cases. So if any manager ever asks you to see his test cases, ask him for help. How should I show you my test cases? You use management cases, right? See, complex cognitive work is not modeled in the terms of cases. I don't think, not very usefully, certainly. So when people keep talking about test cases, testers have been talking about test cases forever. So what is it? Well, lots of definitions. I went out to Wikipedia to have a look, and what I found was this. A test case is a set of conditions under which a tester will determine whether an application or software system or one of its features is working as it was originally established for it to do. I see some problems with that. I hope somebody goes out and edits the Wikipedia page. One of the problems is that after we have started to build the product, and after we've run into some obstacles, and after we've made some discoveries about how it should be built, we're going to change the product. So the originally established part is questionable, and it's testing itself that helps to straighten out the problems that we encounter when we try to build something. We find out that there are problems with it. There's another problem too, and that is that we can't prove that a product works. We can't, by testing or by any other means I'm aware of, prove that a product will work perfectly for all people at all times and in all circumstances. It works is a very ambiguous term or a way of saying something. What we're saying is it appears to meet some requirement to some degree, but people have different requirements for a product, different needs, different desires, and those needs and desires often conflict. So something that works wonderfully for one person is not working at all for another person. Something that is a bug to somebody is no big deal to somebody else. Wikipedia goes on, it says, in order to fully test, in order to fully split an infinitive, that all the requirements of an application are met, there must be at least 2 test cases for each requirement, 1 positive test and 1 negative test. And I sometimes have fun asking testers, so if you do something that's not supposed to be done, then an error message comes up. Is that a positive test or a negative test? Awfully confusing for people. Notice what has happened in this little bit of Wikipedia discourse is we slipped from test case into tests. Now, I agree with the idea that we should be doing testing, but the idea that there should be 1 positive test and 1 negative test sounds pretty silly to me, because it means apparently only 1 thing can go wrong on each requirement. Or maybe 2. Maybe there'll be a problem with the positive test and a problem with the negative test. But really what testing is all about, it seems to me, is finding out whether there are problems. Here's what the ISTQB says about a test case. It says it's a set of input values, execution preconditions, expected results, and execution postconditions developed for a particular objective or test condition, such as to exercise a particular program path or to verify compliance with a specific requirement. Well, first of all, if only they had said or, and if only they had included the fact that a test is an activity. And this becomes a problem, you see, because when they talk about test cases as being a set of input values and preconditions and postconditions and expected results, there's no actual action that happens, because when they say, or when we ask them what a test is, look in the ISTQB glossary, what we find is that a test is a set of 1 or more test cases. No activity. No! So in the rapid software testing namespace, what do we say about a test case? In rapid software testing, we say a test case is a set of instructions or some data for testing part of some product in some way. Now notice the all the sums in there, and the part of the product in some way. Notice that this is fairly non-specific, and that's because whenever we see a test case, it says something explicit about some conditions of the test. But a test isn't just that. A test isn't just what has been made explicit. A test is full of tacit knowledge and tacit activity and learning, all of which are engaged in and applied by the tester. A test is an activity. It's not an artifact, and a test case only says something about that activity. Now, there is something useful in the ISTQB definition of test case there, and that is the concept of a test condition. I like the idea of a test condition. And in RST, James and I developed this after lots of arguing with each other. We developed this notion of what a test condition is. A test condition is something that could be examined in a test or that could influence the outcome of a test. So as we develop models of the product, we identify specific conditions that we might want to test sometimes. We design a test that exercises those conditions, and we design a procedure, and then we perform the test. Now, here's what happens that through that flow there. Part of what we're doing is visible and within our consciousness, but kind of like an iceberg, a lot of what's going on is below the surface. So there's a waterline, kind of a waterline of our immediate awareness. And bits of the model and bits of the specific conditions and bits of the specific procedure and bits of the test are above the waterline. They're visible to us, and we're conscious of them. Now, there are also, of course, incidental conditions that go into the test, things that are tacit about the procedure, things that are not specific in terms of the conditions, and things that we're not aware of in terms of specific conditions that we could specify. So a lot of the time in industry, things look like this. There's a model, a representation, and people generate a specific procedure to follow, and that stays way up above the waterline, and the rest of the stuff stays down below. And the activity of the test and the specific conditions and the incidental conditions get buried a lot of the time under procedure. In other words, we specify what to do, but not so much what to look for. And there's a reason for that. And that is specifying everything to look for would be incredibly difficult. A lot of the time we stumble onto problems when we're testing, and the procedure does not identify how that happens, and the specific conditions that we might observe that might become apparent to us all of a sudden are not specified either. So that's what happens there. The model and the specific procedure are above the waterline, everything else is down below. Maybe it's actually even worse than that. Maybe the model is itself kind of suppressed and the focus is on the specific procedure. We'll see an example of that in just a couple of minutes. And the incidental conditions and the behavior, the activity that's happening during the test, that's all suppressed and kind of below the waterline. Here's what we suggest. Instead of focusing on the specific procedure, what we do is we bring specific conditions to the surface. We bring the activities in the test up above the waterline, and we try to bring those incidental conditions closer to our observation. We pay more attention to the model, and we don't worry so much about the specific procedure. We get testers to enact that procedure, and we don't specify that in advance. We allow the tester to induce variation into the test because that's how we discover things. We discover things mostly in terms of variation. We'll talk about that a little better. So let's try to get the specific conditions, if we want to examine them, above the waterline and not be so specific about the procedure. And then let's feed back. Having been through the experience of a test, having learned something from the test, let's feed that back into our model so that our model rises, more and more of it becomes apparent above the waterline, so that we can apply what we know about the product to the product itself and feed that back into more testing. Here is something that I got from a client. I've obfuscated it and changed what is actually being tested here and the conditions, the specifics that are being observed. But this is what we see in a lot of cases from when we walk around and look at how people are testing. And what we see is an expected behavior that is extremely limited in terms of what is being described and what the tester is being asked to look for. What I noticed when I analyzed this particular sheet, there are a bunch of activities to perform, and when you click the off to the left here, you can't see it, but the activity here is to click on a column header. And when we click on the column header, the transaction should be sorted by account in descending order, and the result that the tester got was same as expected. And then immediately the next step after that is to click on the column header again, and now the transaction should be sorted by account in ascending order. And then once again the tester is reported same as expected behavior. You can look at this for quite a while and not notice something interesting about the sheet where it came from. And that is that there's no specific data, there's no attempt to vary the data, there's no indication of how much data is being used. Is it a single page? Is it multiple pages? There's nothing to indicate how the tester might add richness to the test. There's nothing to identify to the tester specifically that performance is a consideration. Maybe sorting this list, if it's a large list, maybe it'll take long enough to do that the process will time out, the tester or the user won't see an update for quite a while, and the user will come to believe that the application is hung. There's all kinds of things that are going on in a tester's head, in a skill tester's head, that are not captured by the test case. So our focus is on trying to deprecate the test case as the artifact of testing, or as the center of testing. Get rid of the notion of artifacts as being central to testing at all. Because what happens when we get people focused on test cases is we get a long, long row of same as expected behavior and the conclusion pass. But testing isn't just about passing and failing. In fact, whether a test case passes or fails is not particularly interesting. That may sound surprising to you. What is interesting is the answer to this question. Is there a problem here? That's what we're doing as testers. We're looking for problems in the product. We're looking for problems that matter. And a test case can pass, and the product can still have lots of problems in it. Meanwhile, a test case could fail, and it's not really a problem. An example that I give to people is imagine just a simple calculator, and when you ask for the square root of 2, it gives you back the answer 1.4142136. Is that correct? Well, it's not correct. It can't be correct because the square root of 2 is an irrational number and it never terminates. But I think most people would say, yeah, 7 decimal places, correct to 7 decimal places, that's probably okay. So we're not focused on correctness as testers, or if we are, I think it's a mistake, unless the correctness is relative to some problem. So what do we do in order to get some better testing out of this? No test cases? Well, test cases themselves aren't terribly bad things, although they tend to bring over focus to testing. The problem that I observe, and I see this at conferences, I see it at client sites, I see it in both casual and informal discussions with testers, conversation with testers. When I analyze testing that's being done in an organization, what I see is a fixation on test cases, and that's a real problem. Instead of thinking test cases, yes, we must use test cases, or instead of saying, no, we shall never have test cases, let's think about something different. Let's think about it in a slightly different way. Let's think about the degree to which testing has to be formalized. Because there's a big, whoops, oh my goodness, there's a big problem in our business, and that's the problem of formality bloat. Most of the time, your testing doesn't need to be very formal. And most of the time, in fact, your testing isn't very formal. Most of the time, you're not working in a regulated environment. Most of the time, you're not obliged to follow any specific procedure. And sometimes, if you are in an environment where there is some kind of regulation or some kind of requirement to demonstrate the product, maybe you want to do that formally. Another another place where you want to do a formal test of a product, something that must be done in a specific way or to check specific facts. One thing you might be doing formally is a demonstration of the product at the end of a sprint. And you might want to choose to do that in a particular formal way to demonstrate to the client that the product can work. But even in those cases, even when your testing has to be formal, you need to do lots of informal testing in order to get there. In order to do excellent formal testing, it needs to be grounded in informal testing. Now, you might think that the regulators would not cotton to that terribly well, but in fact, that comes from the Food and Drug Administration. The idea that in order to get to what they call the pivotal stage in regulated environments in the FDA guidance documents, they say quite specifically the pivotal stage of testing, where they're essentially performing a demonstration for FDA auditors. They say that has to be grounded in excellent exploratory work. You do that kind of formal testing to make the auditors happy. You do informal testing to make sure you don't lose money or blow things up or kill people. And in fact, there's another reason you do informal testing, and that is because it's part of the progression of going from your first observation, your first encounter with a product, and the formal testing. What seems to be not very much noticed, people who are preparing automated checking, people who are preparing scripts for other testers to follow, yikes. What happens in the process of creating those things is that lots and lots of bugs are found. I remember one time my colleague Adam Goucher getting very excited about the idea that I touted and that he had observed lots of times in his practice, and I bet you all have too, is that as you're preparing automated checks, you bang into problem after problem after problem with the application. You report those, and lots of those problems have to get fixed before the automatic check will run properly. And then once those problems have been fixed, the automated checks never ever find another problem. Things stay stable in reference to those automatic checks, in reference to the problems that you found. Now they might detect problems when the product is changing rapidly, but again, getting the automation to run in a lot of cases requires those bugs to be found and fixed. So what happens as we analyze the product, as we prepare things called product coverage outlines, which we'll talk about in a sec, as we identify specific conditions to be tested, as we create test scripts, we find lots of bugs, and those bugs get fixed such that repeating that process invariantly will not find more bugs. So, see, the thing is that people get confused about what managers really want. What do managers and developers really want from testers? And a lot of people think, well, they want test cases, or they want counts of test cases, or they want pass-fail rates. Pass-fail rates being probably one of the silliest things we provide in testing. Nobody cares, not really, about the pass-fail ratio. They care about something else. They care about problems in the product. What they really care about is this. Are there problems that threaten the on-time successful completion of the project? And I think those pass-fail ratios that they're asking for is a kind of proxy for the actual question, which is what's going on in the project. No percentage, no ratio will give you any real serious indication about what's going on in the project, because you can easily double the pass rate of any product that's being set up in this silly way. The easy way to make the pass rate double is just to run more passing tests, or to maybe not run the tests that are failing. That's gaming the system. Here's what we want to do. We want to find out where those problems are, where those failures are, and we want to investigate those things, and we want to study them, and we want to fix them, and we want to learn from every instance of that. So that's what managers really want to know. Managers want to know, are there problems that threaten the on-time successful completion of the project? But there's a problem with that, and the problem is that a lot of managers get kind of uncomfortable with the idea that building a product, developing it, testing it, is an exploratory process. We don't know exactly from the outset what we're doing. We have to discover that as we go through the process of building the product, encountering obstacles, realizing that we didn't understand the problem as well as we might. Lots of that stuff happens without specific pre-existing instructions. There's lots of tacit knowledge that gets applied. There's lots of discovery. There's lots of investigation that goes on, and that's not scripted stuff. But for those managers, they're a little bit uncomfortable with it because it's like a mysterious cloud, when what they want to think of is specific, discrete tasks and outcomes, like piling bricks. Your wall requires this many bricks to build. Once you've assembled this many bricks, you're good. Or we know how far along we are. But that's not the case in testing. Not the case in product development. So how do we solve that problem? Well, one of the ways of solving that problem is to put the mysterious cloud into a fake brick. And the fake brick that we use in rapid software testing for that appeals to the fact that there are three forms of test management. People-based, where people get handed responsibility for the work and mysterious stuff happens and they come back. Or we can do things artifact-based, and we can account for work products that are legible, tangible, describable. And we can talk about test cases that we created, and once we got a certain percentage of those done, we claim that we're done. But of course, that doesn't account for the discovery part. Here's the way we do it. We talk about activity-based test management, accounting for things that testers do in bursts of sessions. Typically 90-minute or so little activities of uninterrupted testing in which we examine the product and we interact with it and we experiment with it, and we explore it, and we learn stuff, and we take notes. We keep records of what we're doing. We record our observations, we record our feelings, we record the conditions that we're aware of that we tested. We use tools in order to help us with that. We use logs if we got them available. We use video to capture it. We produce reports of various kinds, spoken reports, verbal reports, written reports. When people deem it necessary, we can accompany those reports and illustrate them with data that we've generated, with information that we've obtained. And in this webinar, we're not going to go over all of the moments and the movements of session-based test management, but it comes down to the idea of a time box, a charter, which is a mission statement for a session of testing, reviewable results, and in the formal version of session-based test management that James and John Bach developed in 2000 or so for Hewlett-Packard, because they wanted, the managers at HP wanted very specific awareness of what the testers were up to. There was a formal form of test reporting called a session sheet, but you don't have to do that. You can be as informal as the people are comfortable with, and you can be as formal as the task demands. All this accompanied by what is actually the most important part, I'd say, of the approach, and that is to have a conversation between the tester and the test manager, or the test lead, or the development manager, or the developer, in which we talk about what we've learned, and we back that up with session sheets and reviewable results of various kinds. The idea is to take the mysterious, cloudy aspects of experimenting with the product and turn those into little bursts of activity that are reviewable and describable. So what we're going to talk about, instead of focusing on test cases, is to broaden things a little bit, give testers some freedom and responsibility, but also to guide them in a task that they're going to perform. Now, how do you do that with a product that you're new to, or a feature that you're new to? What we would suggest is you start with sessions guided by learning-focused charters. We might want to look at intake sessions. Here's a couple of examples of that, in which we're trying to discover what our mission is. We talk to the project manager and we ask about particular concerns or risks. We read through all the new use cases that have been developed, and it's a pretty good idea to do that, in fact, pretty critically. One thing you'll notice about use cases is, in a use case, everybody is following the rules. Everybody is using the application properly. Everybody's very well trained. Nobody sneezes in a use case. In a use case, nobody gets interrupted by their boss, nobody gets distracted, nobody makes mistakes. There's a nice, tidy set of preconditions, and then a set of steps that they follow, and then there's a set of post-conditions to observe, and everything is very arid and not rich, and not very much like real life. You know, calling them use cases, I think, is pretty misleading, in the sense that what we'll see when we actually watch people using a product is we'll see lots of interruptions, lots of variation, lots of distractions, lots of other applications running at the same time on their machine, lots of activity going on that's not captured by the use case. So one way to get around this problem, it seems to me, is to recognize the possibility that somebody might plausibly misuse the product. And so we can add to our suite of use cases misuse cases, or maybe somebody's going to use the product maliciously, an intruder or a hacker, or somebody who's trying to steal some information from us. Then we have abuse cases, and we can also look at obtuse cases and abstruse cases, and well, let's look at loose cases too. So once those intake sessions are done, or as they're being done, we might want to learn the product using a survey session. Now, here's an example of doing this. We can familiarize ourselves with the product by performing a UI tour. We create a product coverage outline. A product coverage outline is a kind of map of our ideas about the product, and we'll see some examples of those in just a moment. Here's something we could do. We could do some setup sessions after we've done our survey sessions and learned about the product. We can develop a library of mind maps for each of the major feature areas and use the mnemonic San Francisco Depot: structure, function, data, interfaces, platform, operations, and time as a checklist to see if we've covered the product in a diversified and a deep kind of way. Another thing we could do is we could use tools to go through the executable of the product, decompile the resources in a Windows program, or look at all the different places in which we might see the string error, identify and list all those out, and create some maps of those. We could develop a playbook of scenarios with subject matter experts and with other testers. We could review requirements documents or use cases, or we could look at specifications, and for each one identify ways in which the user could accidentally or maliciously misuse the feature. So we learn about the product by touring. Now I've used a little, as an example of this, we've been using for quite a while XMind, the mind mapping software, not only as a tool for helping us organize our ideas about what we're testing, but also as a subject of testing itself. So what we're going to see over the next couple of slides is what happened when I looked at XMind and surveyed it for what's available there to be tested. On XMind, there's a kind of home page which identifies a bunch of options that we could visit, workspace and new project and stuff that's in the cloud and recent files and files that are currently open. And then when we go to the main workspace page there, the main canvas, and we look over the screen, we see a caption bar, we see a menu, we see a button bar, we see client window, side panel, and then we go deeper. We look at the caption bar, and there's the title of the map, and then there's a minimize button, a resize button, there's a close app button. And then when we walk through the file menu, we find that there's a bunch of options there: file, edit, view, insert, modify, tools, window, those things. When we click on them, they drop down. Then there's a button bar. The button bar has buttons labeled home and save and undo and redo and insert topic and so on and so forth. And then we continue to go deeper. There's a side panel in XMind's GUI, and on that side panel there are drop downs for your outline, for formatting what you've got on a given, highlighted on a given node. So there's a workbook sheet sort order listing for outline, and then there's a format dialog that has a bunch of other stuff in it, and we're going deeper and deeper and deeper, exploring the product and exploring each one of the features by going deeper and mapping it out as we go. As we do that in the course of our survey session, we take notes. We keep our test notes, so you can see the other side of the mind map that I've been developing here for XMind. I'm noting bugs as I go, and you can see that I've listed a few of them there. I'm also identifying issues, that is, things that are making testing harder or slower, things that are getting in the way of testing, slowing things down, obstacles that I'm running into, questions that I have, stuff that's not been made explicit in other places in what I know about the product. I'm also beginning to develop a risk list, so I have a node for that on my little testing node there, subnode of testing as risks. I have test ideas that I'm developing, and I'm making some general notes about stuff as I go. So I'm recording stuff, and I'm discovering bugs while I'm learning. You can see here some of the bugs that I found in my initial explorations of the product or the feature as I walked through it. And then I'm starting to develop a risk list. I'm noticing that the product is slowing down as I'm adding more and more nodes to it. It's getting harder and harder for me to navigate. It's taking longer to refresh the screen when I'm making modifications. So it seems to me that maps could slow down if they get moderately big, and that's a concern I have. The Pro version, if I'm registering that, maybe I'll encounter some problems in that. So I'm starting to develop in parallel with that ideas about how to go deeper later on, using a tool to create a great big mind map to do stress testing with. I'm also discovering, as I'm working, I look at the file and I look at some of the things that are available online about it, and what I discover is that the file format is actually a zip file. It's disguised as an XMind file with XML embedded inside, and that gives us lots of opportunities. Now that we know how the data structures work, gives us a lot of opportunities for automated checking. And while we're learning, we identify issues. Here, for example, some of the things that I can't test because I'm working with the publicly available version of XMind are features in the Pro version. So Gantt chart, export to Office, slide-based stories, and brainstorming modes, and setting passwords, and so on. All the icons that are available being claimed by the product, those are things I can't test. I don't have access to them. So I will talk about those things as a tester. I'll talk about those in a debrief with the test lead or the test manager. And that learning gets fed into analysis sessions for deep coverage ideas. In later sessions of testing, we'll feed our learning into things that we will use to test the product deeply. So we identify the primary components and interactions with external apps for compatibility testing, for security risks. We look at the OWASP top 10 security risks page, see if any of that stuff applies to this product. We look at competitive products, so we can develop a deeper understanding about what features might be available, done better in other projects, or in other products done really well in ours, so we can say yay. Then we realize that there are older versions of XMind and people might be upgrading, so we brainstorm a risk list for what happens when legacy data gets updated, converted. We have a tool, a tool that I'm just making up for the purpose of this example, but it's a finite state model, a generation tool. So we got something called State Maker, and we generate a finite state model for that product for XMind using State Maker, and we can identify tasks the user might perform and steps along the way, and create a state model for the product. We could talk about platform dependencies. We could use tools to generate data of various kinds of size, various kinds of complexity. We could also gather ideas to compare our testing with what we're seeing in the support logs. And we can feed the support log information into the design of future tests. Now, just in case you're worried about this, can we do this in a regulated environment? Can we do this with other products? Of course we can. This isn't just about testing XMind. This is about the patterns of testing any kind of product where we're looping from surveys into analysis and learning sessions into deep coverage sessions. Now, we might not be starting from a built product either. We might be starting from a requirements document or a particular specified function or feature that somebody wants in the product. We could be starting from a design, a mock-up, a map, no problem. Maybe we're at a feature meeting and people are just talking about this stuff and it hasn't been developed yet. It's our job as testers to go to that feature meeting and learn about what people have in mind, to sketch it out, to map it out in our heads, or to create lists of things that we might want to cover, lists of test ideas. And what we'll do here is we'll step through some things. A colleague very kindly donated this, obfuscated it for me, so we could use this for this webinar. Here is something we've made up a fictitious name for the bank. We call it Cash Bank, and they've got a new feature called Insight, where the customer can log on and see all kinds of stuff about their accounts and about their details and so on. So as we explore the product, we go deeper, and we study the specifications and generate this a list of things that we might want to test, creating what we call a product coverage outline. And after we study the specs, we model more of the test pace. We look at, we discover things that are in the product and patterns of behavior in the product. For example, that common icons drop-downs area there, those are things that are going to be common to a lot of different pages, so we identify those as things to be covered in various places. And now, having created a coverage outline for the product, we bring in the client and we talk about it. We talk about what's going to get tested and what's not. One way to do that is to illustrate, for the purposes of trying to manage the project and trying to identify what stuff is going to get covered, how and when. Color is a useful way to do that sometimes on a mind map. What we've got here in green is the stuff that is going to get a lot of test coverage. In red, negligible coverage, maybe because we've looked at it before, or maybe because we consider it low risk. And then in the yellow state, we've got stuff where we're going to do fairly surfacey, not deep testing of that particular area. And we negotiate that, because one thing that's for sure is these maps of a product can get awfully big and awfully deep, and there's some things we're not going to test. So it's a good thing to be able to talk about what will get tested, what won't get tested, unless things change, and negotiate that with the client. Might be a good idea to focus on the riskiest stuff. So in this particular case, the holdings feature was new and potentially complex, so that gets selected for deep coverage. And then the other features, the summary, well, there's been just some updates and some minor fixes to that area. And then the history and future and money movement areas of the product, those have been established, so they're not going to get very much testing. They might get incidental coverage at that point. So we divide stuff down into feature areas, and we look at that product, or we could look at it in terms of interfaces. We could look in terms of particular elements that we want to exercise. And those refreshes, those were new to this particular project. So we identify those as getting extra focus and a deep coverage. And the other stuff is getting essentially sanity checking. So we get more comprehensive ideas for deep coverage, and we might develop scenario playbooks, lists of scenarios and ideas for that. We might run tours based on state machines that were generated by our state model tool. We might analyze the data and see how it gets transformed cradle to grave through the product. We can help the developers to set up automated checks for coverage of stuff that's happening at build time, so we can identify checkable regressions. Then we can go deeper in terms of the error message collection that we did, generate through scenarios or through particular activities, generate each one of the error messages in the product, and then probe the product for possible data corruption, state confusion, missing error code, those kinds of things. Then we can also develop scripts running below the GUI and identify performance issues, timings, to run transactions continuously. One of the things we can do is we can inject deliberately erroneous or invalid data entry and see if the application handles that properly. Now, one thing that we might do at this stage, if we want to demonstrate to outsiders, people who are not involved directly in the testing, the sorts of things we do, one thing is that we can formalize some of the chartered work and describe it deeply. Now, you'll find this stuff in the rapid software testing appendices, some examples of how this got done by James and Jordy Kett at a client one time. What they did was they developed a set of scenarios that involved a good deal of detail so that we could assuage the doubts and the worries of clients who said, well, how do we get supporting testers involved with this, people who don't do testing all the time? And so what we did here was to create a set of protocols by which people would do formal testing, identifying themes or charter statements, specific activities for those people to perform, how to set up for the test, and notice that we've got here is guidance for the tester, but we're not programming the tester. We've got sets of activities for the tester to perform, and we're deliberately not too specific about what the tester is doing so that the tester naturally introduces variation and experimentation into things. Now we're going to do this very quickly because I want to show you the contrast between test casey, formal testing and stuff that is a little bit looser and yet is more inclined to find some powerful bugs. So let's have a look at that and put this question in the table. Is this good formal testing? This is for a medical device that was designed and developed by a company that both James and I have worked with. And these are some of the instructions that we discovered when we went into this company and found out that this is how they were testing a device which consists of two boxes, a control box and a zapper box, and the operator sits at the control box, and then the zapper box delivers healing energy into the patient. Does this look like good formal testing? Well, I worry about it. I worry about it because, well, as you'll see in a moment, there's a lot that it leaves out. First thing to get done in this case is to get rid of lots of stuff like this. Because instead of following a script, what we want is testers to experiment with the product. Now, sometimes there are specific items that have to be checked. And so in those cases, we specify what those are. We specify the conditions, but we don't necessarily specify the procedure, and we certainly don't specify the only thing that the tester is supposed to observe. In this protocol of testing, yes, we use verify to highlight specific items to be checked, but we also prime the tester to be aware of anything that's unexplained or erroneous, and there is a general requirement for any specific test. On top of that, there's a general requirement that the product shouldn't kill people, it shouldn't harm patients, and it should deal reasonably when there are circumstances in which somebody might mistakenly, reasonably trigger some kind of condition. So we got to be on the alert for the possibility that people will vary their behavior, and the product needs to respond smartly to that. In order to do that, we need a skilled tester. And so rather than specifying every little thing for the tester to do, we want the tester to be deeply familiar with the functional requirement specifications and with how the products are supposed to work. If the tester doesn't have that, tester is not going to do well. So the other thing that tester needs to be familiar with, another thing, is the test equipment, the power test equipment and the software that goes with it, how to set it up, how to figure out if it's working right or not working right. Tester should be able to perform statistical analysis for this product. It's a complex product, and it has to perform very reliably in very precise kinds of ways. So the tester needs to do all of that, and the tester also needs to know how to keep good notes. The problem with that formal specification that I put up on the screen a couple of slides back is that it says to turn on the boxes in a specific order in the test, but the specification doesn't say anything about that. So it doesn't, and the user documentation didn't say anything about that. And so it'd be easy to assume that it doesn't matter. But in the first minute of an exploratory sanity check, the test team found out that it makes a lot of difference whether you start the zapper box first or the control box first. Here are some of the things that they found out. When you start with the zapper box off and the control box on, then, the zapper box off and the control box off too, You turn on the zapper box, and depending on when you turn on the control box, you get very, very different kinds of behaviors. And in certain cases, you are able to zap when you should not be able to zap. That is to say that the device is live before the controller box is ready to control it appropriately. So that's something to look out for. Now, a better way of specifying to the tester what to do, it seems to us, is to be a little bit more general, to give the tester this set of instructions and to say, go look at this for some period of time, from anything from a few minutes to an entire session. Start the boxes in various orders and timings. Make sure you're collecting the log files. Note anything that seems to be inconsistent or unanticipated. Look for conformance to the requirements, but also look for anything that could get in the way of safety. With the system settings at their default values, vary them, change them, go through all the range of possible values for the field, not just one, and make sure that the values appear correct, everything on the screen appears normal and accessible, and then give a reference to the log files and look back at that and examine what's going on with the product there. And then repeat certain steps at the extremes of the ranges of acceptable values. Use various different ways of editing fields. See, after we've learned and tested, we can decide on formal testing in cases where formal testing actually matters, where formal testing would be a good idea. So let's have a look at an extremely specific, whoops, this is from another thing here. There we go. Extremely specific test design. If you need that, then specify it at that point. And when you look at this, you're thinking, woo, statistics. You mean the tester is going to have to be a statistician? Well, in this particular case, when people's lives are on the line, when the power has to be delivered to the patient in such a way that it doesn't harm the patient, or it also doesn't harm the patient by being insufficient amounts of power, or by the power varying too much, then the tester needs that level of skill. And that's something that we need to aspire to. We need to learn quickly and rapidly how to perform these kinds of activities. So, yes, testing like this does require skill. But, you never see an airline saying, well, we wanted to go with a skilled pilot, but skilled pilots, oh, they're so hard to find and they're so expensive. Airlines don't complain about that stuff. They hire skilled people to start with, and they continuously train them and retrain them, reevaluate them, put them through increasingly challenging conditions. Testing's value is directly related to the skill of the testers. So hire or train testers with skills to tell the testing story. Testing isn't about reporting your test cases. It's about reporting the status of a product, what it is, what it does, how it works, how it doesn't work, how it fails, how it might fail in ways that matter to your client. That's a story about bugs. But in addition to that, we also need to tell a story about how we tested the product, how we configured, operated, observed, evaluated, how we recognized problems, what we have tested, and what we haven't tested yet. That's where the coverage outlines come in. That's why those things are important, to develop and to maintain those, to help us see what has been covered and what hasn't, so that we can make the client aware of the risks, not only of what we've been looking at, but the risks that are hidden in all the stuff that we haven't looked at yet. So that second level testing story is a story about oracles, and it's a story about coverage. And finally, we need to tell a story about how good our testing was. What made testing harder or slower? Why we're not able to cover the stuff that we're not able to cover? What we need or what we recommend in order to make that possible? The dimensions of testability that we might need to add in order to make testing go faster, more easily. That's what testing is all about. Now, one way to visualize progress is to summarize the charters. and to show how we're making progress. What we've got here on the screen is a bunch of charters that have been reduced down to a couple of keywords. The extra testing notes are available for everything under there that's done. There's a little test report referring to 90 minutes or so of testing, or a half a day's worth or an hour's worth or whatever a period of time you like. And as each task gets accomplished, we move it over and we make that progress visible. In terms of test reporting, there are lots of ways to go about it. We can use mind maps annotated. We can develop formal reports. We can have informal test notes. We can summarize a session of testing using the session-based test management session sheets. All kinds of different ways to do that. Most importantly, though, all of these things are artifacts that illustrate conversations. They represent what we would say to people if they were there, and in fact, they're things that help us to frame a conversation, because inevitably people will have questions about our reports. But those people who are asking us for test case documentation will forget about that when we give them something that's more credible, more thorough, more believable, and when we talk like we know what's going on. So with that, what I hope I've identified here is that testing can be a lot richer than being reduced down to straightforward, simple, and basically misleading kinds of procedures that encourage testers to behave in a very rote, mechanical kind of way, and that what we need to get good at is describing what we're going to cover and then talking about how we've covered it. And that is the end of the material, and I hope we have some time for questions.
Thank you very much, Michael, for that. That was really great. Lots of great feedback. Before we go to the questions, just I have one or two other things I want to share with our attendees here today. The first of all being that we have more great webinars coming over the coming months, and you can see these webinars here. And to register for those, just head over to the Huddle website and just go to the upcoming webinar schedule. We continuously add new webinars to that all the time.
Okay, that's great. Oh, look at that.
Yes, our program is now live, and we encourage you to go over to the EuroSTAR site, check it out. You can see the different sessions we have, including the various sessions that Michael will be talking on, his full day tutorial on critical thinking about numbers and metrics, as well as the track talk on transforming trainees into testers.
Yeah, that's going to be, I'm really looking forward to that, because that's the second time I'm going to be in Copenhagen this year. That's wonderful.
Great.
Yay, Copenhagen.
And we have another conference as well that's taking place next month. It's a one-day event in Oslo on May 11th called EuroSTAR. So to find out a bit more about this brand new EuroSTAR conference, then head over to the EuroSTAR site there. You'll see the link there, euroStarSoftwareTesting.com/EuroSTAR. So now let's have a look at some of your questions here. Now we've gone a little over time, but we'll take a few questions anyway.
Well, absolutely, let's hang in there.
So the first question I see here, Michael, this person here is asking, how is informal testing defined?
Informal testing. Well, it's easier to define testing in terms of formality. That a formal test is one that must be done in a specific way and or to check specific facts. And a test is formal to the degree that it must do that. A test is informal to the degree that it does not have to do that. So it does not have to be done in a specific way. It is not targeted towards specific facts. And the reason that that's important is because so much testing, so much bad testing, is focused on confirmation, showing that the product can work, that it can do something. But that's not really what testing is about. It's not really what science is about, what research is about. Research is about discovering something new, not showing that the product continues to work. Now, a lot of people get head up about, well, what about regression? Well, regression is a specific kind of product risk, and we can do testing focused on that. But you know, if we do testing without a specific focus on regression, we can find regression problems, and we can find other problems too. So let's relax on our sort of fetishes about regression. Regression is not the only source of product risk. And a test that we've run before, lots and lots of times, done in exactly the same way, lots of times, is going to lose its power to find bugs over time as we fix problems related to that set of conditions. There are other conditions that we need to examine too. That's an important dimension of test strategy. Actually, I'll be talking about, it's funny that Copenhagen comes up. I'll be talking about test strategy in Copenhagen in end of May. Have a look at, sorry, middle of June. Have a look at my my website for that. All right, next question.
How can you transform from very formal test case driven to session based approach when people just don't get it?
The first thing I would suggest is try a little experiment. In places where testing is very, very heavily formalized, I've noticed something. The reason it's formalized is because people don't trust you. But of course, the reason they don't trust you is probably because they don't know what you do. And if they don't know what you do, how do they get to that stage? Because they're not watching you very carefully. So one of the things that I would suggest is sneak an informal session of testing into your work. Everybody has time when they're not being scrutinized, when they're not being watched. Nobody has time to watch all of their employees every minute of every day. So what I would suggest that you do is you sneak some informal testing into those little bursts of windows of what we call disposable time. Disposable time is the time that you can afford to spend or even waste without getting into trouble. And if you use that well, then that's great. You'll have learned something, or maybe you've discovered a bug, or maybe you've tried a little experiment, or maybe you've built a little script that can help you in some way. Well, you can use that kind of time, those little bursts of time when you're not being directly supervised or directly scrutinized, in order to do a little experiment and to see what you find using informal processes as well. Let me note this, though. While we're at it, if you want to convince somebody, customers find bugs. Customers find bugs. Customers encounter bugs. Customers stumble into bugs. And they do that specifically because they're not using the product in a formal way. Customers users are deformalized kind of people most of the time. And that's how they encounter problems. It's because they're not doing all the stuff that they've been told to do. It's because they're not following the rules. It's because they're not doing the stuff that's they're being told to do in the user manual or the tutorial. They are engaging with the product and interacting with it in varying ways. So try little bursts of that, and then keep notes on the proportion of time you spend versus the what you learn. And it's not always about bugs, of course. When you're interacting with a product informally, maybe you're not finding that many bugs, but you're learning about the product. You're learning about how to cover it. You're learning about where there might be bugs. You're learning about hidden or surprising features. You might even be discovering novel uses for the product that would be useful to the marketing people or to the documentation people to describe as a feature of the product. So do little experiments. If you can get permission to do that, that's fantastic. If you can grab a bunch of people and have them perform testing on the product with a much looser set of instructions than testers are sometimes given in these places where testing is formalized, do that and see what you learn from it. But do it a few times because it'll take some time for people to loosen up and defrost their procedures.
Do you generally use a mind map to begin your planning for exploratory testing?
I do these days. I find it's what's kind of cool about a mind map for me, and not everybody will use this. That's okay. There's no best practice here. I find it's a useful way of taking notes and being able to reassemble my notes in ways that I can sort of resort them into categories and so on. That's one thing. The other thing is I often sketch out before I start testing the product. Sometimes what I'll do is I will highlight structure, function, data, interfaces, platform, operations, and time as top-level nodes on my map. And what I will find out fairly quickly is that as I experiment with the product, I'm getting a lot of learning about the interface, and the other nodes are more sparsely covered. And when that's happening, I look at that map and I say, well, I haven't got very much under that data node. Am I okay with this? Maybe I am, but maybe it can be a trigger to me to go deeper and to remind me to think about various ways of looking at data, what gets put into the product, what comes out of it, how it gets processed as it's moving through the product, how combinations and variations of the data might be important and might reveal new learning, make new learning available. Well, I find a mind map pretty handy for that. Now, another way to go about it, of course, is simply to map out ideas as they come to you, right? Let the product come to you and map out your understanding of it. And then after that, if you like, you can use San Francisco Depot, structure, function, data, interfaces, platform, operations, and time as a kind of checklist to nudge you into looking at things that you might have overlooked or that you might have forgotten or that you might not have covered very deeply. So I'm liking that as an approach these days. But there are lots of other styles. People kept hierarchical lists of these things before there were mind maps. They used outline processors. And if you're the kind of person who likes to generate tables, you can do that. There's all kinds of ways you can take and keep notes as you go.
All right, we've gone 15 minutes over, but because we have so many questions, I might just take two more, Michael, if that's okay with you.
I'm here for as long as anybody else is. So I think I got a phone call to take in an hour and 45 minutes. Anybody wants to hang in, they're welcome to do it. Okay. I thank the people who have to go for the attention, and of course I'm available to answer questions anytime. There's lots of different ways to reach me. That slide from my screen identifies some different ways to reach me on Twitter, at Michael Bolton, on Skype, michael.a.bolton, via email. Any tester who wants to get a hold of me can find me pretty easily on the web. All they have to do is include testing, otherwise you get that Singer guy. And I'm going to be in Amsterdam next Wednesday night. I'm going to be in the London area on Thursday and Friday of next week. Uruguay, and for the Europeans, I'll be in Copenhagen in the middle of June. Look those things up on my site, and we can meet face to face, which is my favorite way. So a couple of questions.
Okay, so we'll take the two, and then we'll better wrap it up here. But
as you wish.
I'd love to keep going all day, but unfortunately we don't have the time here. But thank you anyway, Michael, for taking the time out for all these questions and presentation. There's been great feedback. People are very interested in everything you had to say, and very positive comments there. So thank you guys for that. Next question I have for you here says, how would you see sessions fitting into a continuous delivery context where there is also a heavy focus on test cases and the coverage derived from them?
Same thing as I was saying before. Sessions really, when you think about it, sessions are not a unit of testing. They're a unit of activity. So you can organize, for example, if you decide, well, I want to do some scripting and put that into the continuous build pipeline, right? I want these various checks to run. Well, what I would suggest on that basis is set yourself up a 90-minute session in which you're going to develop a certain set of scripts to cover a certain set of conditions. And you know, we have a notion of a session of testing as 90 minutes of uninterrupted or in reality somewhat interrupted sessions. But lots of people organize their work in different ways, and that's cool too. There's the Pomodoro technique, right? 25 minutes of work, 5 minutes of break, 25 minutes of work, 5 minutes of break. You can do it that way. Paul Holland at Alcatel-Lucent, when he was doing session-based test management, simply declared each morning and each afternoon a slot for a session, and they structured their charters according to that. They said, well, how much work can we get done in the morning, or how much work can we get done in an afternoon? And they scoped the task. But the other thing, of course, is that a session, you're not obliged to complete what happened during a session, or what you originally set out to do in a session, because you never know what you're going to find. The session marks a set of time after which we will pause, review, debrief, you know, reorganize, sort out, sift up, wrap up our notes for that particular burst of time, and then decide, report on what we've done, absolutely, and then decide, well, was the original charter accomplished? If it was, yay. If it wasn't, we revise the charter in the report to indicate what we actually did, and then we review the original mission and see if we want to continue pursuing that, or if we want to go in some other direction. So that's why the notion of a backlog of charters is useful, because we can select from that backlog to focus on the most important stuff first, but also to keep track of the other important stuff that might not be so urgent. And then also, of course, inevitably on that list, there'll be stuff that we might not have time to get to, and we can make sane decisions about it when we see it laid out. So in any, excuse me, in any kind of circumstance, you can apply the concept of a session as a chunk of time in which we'll perform some activity, and then we'll review it. So that can work for CI shops just as well as it can work for any other kind of shop. One more.
Okay, great. So last but not least, this person here is asking, how do you decide the test coverage? You gave an example of deep coverage, but what are other kinds of coverage?
Well, deep coverage refers not so much to a kind of coverage, but to a level of it. Basically, coverage itself, a lot of people are confused by the notion of coverage because it's not very well documented in the literature, and so people kind of wave their hands at it. James and I, it took a long time for me to understand it too. James was really helpful with this. Here's what we came up with eventually. Coverage is how much testing we have done of something with respect to some model. And then you can refine that by saying, oh, well, performance coverage is how much testing we've done based on some model of performance. Another example, requirements coverage. Requirements coverage is how much testing we've done with respect to some model of the requirements. So when we talk about depth of coverage, we're really talking about how much coverage we've done with respect to some particular model of stuff. So there's there is kinds of coverage, various ways of modeling coverage, and San Francisco Depot is one, but we could also talk about risk coverage. We could also talk about scenario coverage, how much coverage we've done with respect to some model of scenarios for using the product. So depth of coverage, in a sense, is kind of about quantity. The other ways of thinking about coverage, code coverage, how much testing we've done with respect to some model of the code. Now, of course, you're thinking, well, there's no model of the code is just a code. But think about it, there's code that we've written, but there's also code that we are inevitably executing, even though we didn't write it. Operating system code, file system oriented code, network interface code. So even when we're talking about code coverage, we're talking about a code that we wrote. And there are different ways of thinking about that code too, in terms of line coverage and branch coverage and all those different forms of covering the code, branch condition coverage that show up in the classical talk about code coverage. But code coverage is only one kind of coverage. So lots of different ways to model the product, as many different ways to cover the product with testing as there are ways to model it in your head. So I hope that answers the question. By the way, Dara, if you could do me a favor and give me a list of all the questions that people have been asking. I think the webinar software affords the opportunity to do that. And what I could do, I guess, is I could try to answer those questions if they come with an email address, or even if they don't. Maybe one thing I could do is answer the questions and pop them up on the EuroSTAR blog.
That sounds great, Michael.
Site.
I'll get that together. I'll send you on those questions, and perhaps we can turn it into a blog post that we can put up on Huddle.
Okay, that'd be great. It'll take a little bit of time, so forgive me for that, but I'll try to get to it. Also, Dara, I want to say something that I hope at least some people hear. Is there a formal announcement about to be made about yourself?
No, not that I know of.
No? Okay. Well, I wish you well. Let's just say that.
What Michael's referring to there, guys, is this will be my last webinar as part of EuroSTAR, and I'm moving back towards my hometown of Limerick. So I guess thank you all for coming along today, and thanks, Michael, for the presentation.
I wanted to hear you say that so that I could say thank you for all the things that you've done for me in the community through EuroSTAR. It has been a pleasure working with you, and I wish you well wherever you end up. And pints in Limerick at some point, huh?
Absolutely, absolutely. So that's it from me, guys. Thank you all very much for coming along today. One question that I can answer from the list of questions that are coming up here is this webinar being recorded? The answer is yes. All of our content is recorded here. All of our webinars are recorded, and we'll send you a link to the webinar in roughly an hour's time. So you'll be able to look back at the recording, check out the slides, and stay tuned on the Huddle website, and you'll get to read that blog post by Michael. So thanks you all Dara. Again, and take care. Have a great weekend, everyone.
Thank you, everybody. Bye-bye.